here is the video for the rest of review 1 that we didn't look at in class. So number 8, given f of x as shown in the accompanying diagram, find the following. F of 2. So in the parentheses again, that is your x value. So on the graph, where do we have a point with an x value of 2? We have this point right here, 2, 10. So when x is 2, y is 10, and 10 is our answer. Part B, find the following. We are finding x such that f of x equals 2. F of x, remember, is your fancy notation for y. So this is saying that y is 2. So which x has a y of 2? So we have this point right here is the point 1, 2. So when y is 2, x equals 1. For part C, it says f inverse of 2. So this is saying that x equals 2, but it's saying x equals 2 on the inverse. That is not the graph that I have. I have regular f of x. So if x equals 2 on the inverse, remember, means switch your x and y. It means that y equals 2 on the regular f of x graph because the x is being switched into a y. So here, finding f inverse of 2, you're really looking at the regular f of x graph and finding where y is 2, and the x where that happens is at 1. So B and C are really just the same question, different wording. Part D, we're going to find the element in the domain that corresponds to 0 in the range. So you're looking for the element in the domain. Remember, domain means x's. So you're looking to find the x that corresponds to 0 in the range. And remember, range means the y. So you're looking for the x when the y is 0. So here we have the point -1, 0. So x is -1 when y is 0. Question 9, what are the domain and range of the function pictured below? So domain, starting on the far left, is at -8. If you take a horizontal line and slide it across the graph, your first hiccup might be at -5. Think you need to stop. But because we have something solid down there, you do get to keep sliding. Again, you might feel like you need to stop at the +1. But again, we got something solid there, so we're going to keep sliding. And we're going to stop at +7 where it's open, so we're going to give it a parenthesis. Range, we're going to do the same thing starting on the bottom. So the bottom is down at -8. It is closed, so square bracket, slide up. If you touch in more than one spot, that is okay. We're just looking for the range. As long as you're touching the graph someplace, you get to keep sliding up. And we're going to stop at 4. That is the highest point, and it is open, so parenthesis. Number 10, if g of n equals 5n plus 6, find g of 5. So this time we're using an n in the parenthesis. So n is going to be 5 here. So 5 times 5 plus 6. 5 times 5 is 25. Plus 6 is 31. For part B, we're going to find n if g of n equals 21. So g of n is the entire left side. So we're being told that the entire left side equals 21. And now we have an equation that we can solve for n. We're going to subtract 6 15 equals 5n. Divide by 5. So n equals 3. Number 11, we're going to find g of 5 first with the composition. Remember, start closest to the number. So g of 5, we're going to have 5 squared minus 4. So 25 minus 4 gets me 21. And now we're going to take the 21 and plug it into f. So f of 21, 2 times 21 is 42, plus 3 equals 45. So that is your final answer. Make sure that you know that f of g of 5 is the same thing as saying f of g with an open circle of 5. Either way, you are starting with whoever is closest to that right side to the number in that case. So looking at part B, where we normally have the number, we have an x. So we're starting with the f of x. So here's f of x. So I'm essentially saying plug x in where x is. So that's really not going to change your equation at all. F of x is just 2x plus 3. But now we're going to take this entire thing and plug it into g. So you're doing g of 2x plus 3. So in the g equation where I have the x, I am filling in 2x plus 3. So x squared becomes 2x plus 3 squared minus 4. 2x plus 3 squared, we're going to write it twice and double distribute and make sure you carry that minus 4 down. So double distributing, 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. 3 times 3 is 9. Again, carry down that minus 4. And now combining like terms, I get 4x squared plus 12x plus 5 is my final answer. Part C is asking us to find the inverse. So again, inverse means switch your x and y and then solve for y. So f of x is my y, so switching, I get x equals 2y plus 3. Solving for y, I'm going to subtract the 3. I get x minus 3 equals 2y. Divide by 2. So I get y equals x minus 3 all over 2. Or you can use the inverse notation there, f inverse of x equals x minus 3 all over 2. And then the last question using the graphs on the left is f of x, on the right is g of x. So find f of g of negative 2. So we're going to start with g of negative 2. This is where x equals negative 2. So on the graph, we have the point negative 2, 4. So g of negative 2 is 4, which will now plug into f. F of 4. So this is where x equals 4. So on the f graph, we have the point 4, negative 3. So my final answer is negative 3. For B, closest to the number is f. So f of 3. So again, 3 is the x. So we have the point 3, negative 1. So f of 3 is negative 1, which I'm going to plug into g. Now, x is negative 1 on the g equation. And we have the point negative 1, 2. So g of negative 1 equals 2. For C, this is similar to one of the other ones we did. X equals negative 3 on the inverse of f of x. So that means y equals -3 on the regular graph f of x. So on the graph where the y is -3, the x equals 4. Or you can simply say that f inverse of -3 equals 4.